All right, let's solve another rational inequality. So we notice we've got rational expressions. We have a greater than symbol, so it is a rational inequality. The first step is to isolate. So I'm going to move this entire expression to this side, which makes it a minus. So I have x minus 3 over x plus 4, then minus x plus 2 over x minus 5, and then greater than 0. So now we've isolated the rational expression on one side, 0 on the other. Step 2, I replace the inequality sign with an equal sign, and I try and solve. Okay, to solve this, what I'm going to do is I'm going to find the LCD, and I'm going to multiply every term by the LCD. So the LCD here, least common denominator, is going to be x plus 4, that's this denominator, and this denominator, x minus 5. Okay, now we've done this before, so I'm just going to do this real quick kind of in my head. If I multiply this times this, the x plus 4's will cancel, and what I'll be left with is the x minus 5 on top with the x minus 3. Okay, now when I multiply this times this, the x minus 5's cancel, I'm left with x plus 2 and x plus 4. Don't forget you have the minus sign here. So minus x plus 2 times x plus 4. And then equals 0. Okay, now I will FOIL this out, and then I'm going to collect like terms. So multiplying this times this, you would get x squared, you get minus 3x minus 5x, which would give you minus 8x. Then negative 5 times negative 3 is plus 15. Now be careful here, because you have subtraction. You're going to do minus now. I'm going to multiply all this out, and remember we'll subtract, so we'll distribute this through. But this would give you x squared right here. Then you'd have plus 6x, then you'd have plus 8, and then equals 0. All right, now let's distribute our minus sign through. I'm going to put that right here. So I have x squared minus 8x plus 15. I'm going to do minus x squared. I'm going to do minus 6x. I'm going to do minus 8 equals 0. And now I collect like terms. The x squareds cancel. Negative 8x minus 6x gives me a negative 14x. So the x's are gone. And then 15 minus 8 gives me plus 7 equals 0. Now, this is a linear equation. Move 7 over to the other side, so I get negative 14x equals negative 7. Divide both sides by negative 14, and you get negative 7 over negative 14, which is positive 1/2. So for step 2, solving the equation, you get one solution of x equals 1/2. And we'll just have to remember that. I'll jot it down over here. X is 1/2, so I don't forget it. And now what we want to do is move to step 3. Step 3 says to look at the numbers that would make this thing undefined. And since they're in fraction form, it's pretty easy to see. Here, x could not be equal to negative 4. If it was negative 4, this would be 0. You'd have division by 0. Here, x cannot be equal to 5, because 5 minus 5 would give you 0. So now we've got our points, and we'll move to our next step. Our next step is to, step 4, is to put everything on a number line and then get our regions. So I have negative 4, I have 1/2, and I have 5. Okay, now let's pick test points. So I have to pick something here, 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 and here. So a good test point over here is like negative 5. A good test point here, how about 0? That's a good one. A good test point here is 1, and then a good one here is 6. And what we need to do is plug all of these numbers into the original inequality right here and see what we get. So this is going to be a little tedious, but I'm going to go ahead and do it. So let's plug in first negative 5. So if I do this, negative 5 minus 3 over negative 5 plus 4 minus negative 5 plus 2 over negative 5 minus 5 greater than 0, let's figure out what this is. This is negative 8, so I'll put that right here, negative 8 over negative 1, minus, this is negative 3 over negative 10, greater than 0. So now negative 8 over negative 1 is 8. Minus, now this is a positive number, so 3/10 greater than 0. So what you could do is you get a common denominator now. So in order to get a 10 underneath the 8, I have to multiply the top and bottom by 10. So I multiply top by 10, I get 80. Bottom by 10, I get 10, because that's an 8 over 1. And then 3 over 10 greater than 0. And you can see here 80 minus 3, 77 over 10 greater than 0. And that's true. This is a positive number. It is greater than 0. And therefore, everything over here will work. All right, that's only one test point. We still have 3 more to do. So let me do the next one. For the next one, I plug in 0. 0 minus 3, negative 3. 0 plus 4, 4. Minus 0 plus 2 is 2. 0 minus 5, negative 5. Greater than 0. Okay, now this is negative 3/4. Okay, this is a negative number here, but then subtracting makes it plus. So we have plus 2/5 greater than 0. Now we'll get a common denominator, which will be 20. So I multiply top and bottom here by 5, negative 15 over 20. Plus, now here I multiply top and bottom by 4, 8 over 20, greater than 0. If you combine these two together, negative 15 plus 8 gives us negative 7 over our common denominator 20 is greater than 0. This is not true, right? A negative number is not greater than 0, so this region is no. Now 2 more. Plug in 1, then plug in 6. So let me plug in 1 now. If I plug 1 in here, 1 minus 3, negative 2. 1 plus 4 is 5. Minus 1 plus 2 is 3. 1 minus 5 is negative 4, greater than 0. Okay, we have negative 2/5. Negative, and this is a negative, so it'll become plus 3/4, greater than 0. Okay, now common denominator again. What we're going to have is negative 8 over 20 plus, let's see, 15 over 20 greater than 0. And you can see negative 8 plus 15 is 7, so you'll get 7 over 20. That is a positive number, so this region does work. And now we're ready for our last region. We test the number 6. Okay, for 6, we get 3, right? 6 minus 3 is 3. 6 plus 4 is 10. Minus, let's see, 6 plus 2 is 8. 6 minus 5 is 1, greater than 0. So this turns into 3/10 minus 8 greater than 0. Well, remember, this is going to be common denominator 80 over 10. So 3 over 10 minus 80 over 10 greater than 0 is not going to be true. This is 3 minus 80 is negative 77 over 10. That's a negative number. It's not positive. So this region is no good. So now we're ready for our answer. We want everything to the left of negative 4. We want everything between 1/2 and 5. And that's it. Now the question is, do we include these points? Negative 4. Well, if you go back up and look, negative 4 made our rational expression undefined, so we want to leave that point out. Also, 5 made it undefined, so we leave that point out. Now, 1/2, remember we got that when we set it equal to 0 originally? When we set it equal to 0 and solved, we found that 1/2 was our only solution. But see, 1/2 makes this thing equal 0. And we don't want it to be equal 0, we want it to be greater than 0. So because there's not a line here, we will not include this point. And now I can write this solution set in interval notation. So it's everything to the left of negative 4. That's negative infinity to negative 4. Do not include negative 4. Then unioned with everything from 1/2 to 5, don't include the points 1/2 and don't include the point 5. And that's the solution set for this rational inequality. You plug any number in these intervals into this and it will be true.